We're studying IGCSE Chemistry and we're starting Reversible Reactions and Equilibria, Revision 3. Now in this class, we're going to practice lots of questions and revise anything which we may not be familiar with or may find difficult. Let's start with the first question. Question 1. So this class is directly skill check. Now Anas, read the question quick, out loud.
Okay. Iodine reacts with chlorine to form dark brown iodine monochloride. This reacts with more chlorine to give yellow iodine trichloride. An equilibrium forms between these iodine chlorides. What do you understand by term equilibrium?
Equilibrium. Now Anas, what is equilibrium, you know? Check your notebook. Now tell me what is an equilibrium.
Yeah, I'm trying to find it.
Find it.
Okay, so
Right, tell me.
one second. Is it like when both the reactants are I don't know. I don't have
Read on the screen.
Okay.
Read on it and write in your notebook. So write the word equilibrium and then write this in your notebook. Tell me when you're done writing. Just a second.
Okay.
So just write equilibrium, then put an arrow as the definition, and rate of forward reaction is equal to rate of backward reaction. And we'll say concentration of products and reactants becomes constant. The 2-mark question, Anas. So you need to write these 2 lines for the mark. Point 1, let's just write this as 1 and 2.
Done.
Done. All right. Now, when the equilibrium mixture is heated, read the question next one.
When the equilibrium mixture is heated, it becomes a darker brown color. Suggest if the reverse reaction is endothermic or exothermic. Give a reason for your choice.
Now, let's first look at the reaction. Anas, look. Now, which side is the reactant, right or left?
Left.
Left is the reactant. Well, fine. Let's put that right here. And which side is the product, right? Now, on this, well, we know all of this, fine. What do we not know? What we don't know, one thing. Now, look, what is the change they are making? First, tell me the change. Read the question. What are they doing in the question?
It's changing from dark brown to yellow.
Dark brown to yellow. That's fine. That's fine. And what do you do that this happens? Like, what action is the person doing that causes it to become a darker brown color?
Darker brown color. So
What are they
He-
doing that causes this?
He is doing it again.
No, read the first part.
When the equilibrium mixture is heated, he is heating it up.
He's heating it. So the change is heat, or let's say heating it. Okay. And what is the result of this change?
So do
It
you mean like
becomes,
endothermic or exothermic?
no, I'm asking, when he heats it, what does he see? What does the reaction become? Does
Oh,
it become
darker
dark
brown.
brown? So we'll say darker brown. Now, okay. First, tell me which side is darker brown, reactant or product?
Reactant.
Reactant. So I'll say that. Can I say that equilibrium, because it's becoming darker brown? Can I say equilibrium is shifting backwards or shifting to reactant? Is that happening? Equilibrium is shifting to reactant side.
Yes.
So it's going like this, right? Backwards or to the reactant side. Okay. Now, fine. I'm heating it. Now, what kind of reaction is favored by high temperature? Endothermic or exothermic?
I think exothermic.
No, check your notebook.
Oh yeah, once again. So
Look
yeah,
at the rules for temperature.
endothermic. Because endothermic like releases heat.
No, read the whole thing for me out loud. The rules for temperature.
Okay. One second,
I'll
it's
write
noisy.
it here. Yes.
It's
Tell me.
noisy here. One second.
No worries. It's fine. I don't find it a problem. The next thing is I'll just write it here for you. Temperature rules for just the temperature rules. First one is uh, first thing is high temperature favors endothermic side and low temperature favors exothermic. Now, Anas, read it out loud.
Okay. Temperature effect on EQM. High temperature favors endothermic. Low temperature favors exothermic. Okay.
So now I'm heating it, and equilibrium is shifting to reactant side. So what do we realize about reactant side?
That the reactant side is heating up.
Yeah, but well, I know I am the one who's heating it, so that's fine. Now, look, I have this reaction, and I know I'm heating it. Well, I can see that, but what I realize is heating is causing it to go back to the reactant side. Okay, so what kind of reaction is the reactant side? Or what type of reaction is that backwards? Is it endothermic or exothermic?
Oh, it's endothermic.
And because heating it is causing it to go backwards, therefore must be, therefore reactant side is endothermic. Because heating the reaction is causing it to go reactant. And I know that heating only favors endothermic. So if heating is favoring reactant, that must mean the reactant is endothermic. Right? Understood?
Yes.
But what will we write in the exam? Well, this is the working. We look at, Anas always look at it like this: change and result. Fine. So what is the change they're doing and what is the result we're getting? Now I can write the answer here. The answer is the reactant side is endothermic, and give me a reason. Because why is it
Because
endothermic?
being heated up.
Heat it up. I need something about the rule. You have to mention the rule. Because
High temperature.
higher temperature, then favors endothermic reaction.
Okay.
So that means if I'm heating it, the temperature is increasing, and therefore
Yep.
I realize because of high temperatures going backward, so it must be backward must be endothermic. And let's read
Alright.
the next question.
The pressure on the equilibrium mixture is decreased. How would this affect the position of equilibrium? Give a reason for your choice.
Equilibrium. Yeah,
Equilibrium.
equilibrium. Fine. Now tell me, what are the rules for the pressure? Pressure effect on equilibrium. What are the rules?
It would. How would this affect the position of equilibrium? If it's degrees, right? So it would move to
Press-
the left, right?
Why?
Because it's being decreased. So if
That's
the temperature
fine.
decreases,
But the reason is not correct. Let's see.
Oh.
First, let's write the change. The change. What is the change happening? Changes.
changes, it's being the mixture is being decreased. Pressure.
Pressure is being is decreased. Okay.
Yeah.
So let's just write it. Pressure is decreased. Now I need you to know the rules for these, and they're asking us the result. So we'll just put this right here. The Anas, this is the rule. Have you written this or not? Tell me first.
I wait.
Pressure rule.
Yeah, I think so. Let me check actually.
Because I remember you did. You did say in the class you did. Increasing pressure favors reaction side. Because how will you solve the question in exam then? Because you need to memorize what I gave you in the class. Or at least keep track of it.
I found the endothermic one, but I cannot find the pressure one.
Then do one thing after class, send me a picture of all your notes. Is that clear? For this chapter. Okay? So whatever you have written for this chapter, and I need to check that. Start reading from here.
I don't have a lot of things. It's just
No, I don't.
Yeah.
I don't care. You have to send me whatever you have written for
Okay.
the chapter of equilibria. Right? Now, read it out loud on the screen.
Okay, so pressure effect on EQM. Increasing pressure favors reaction side with lower number of particles. Decreasing pressure favors reaction side with higher number of particles.
What is EQM, Aditya? Not Aditya, Anas. It is equilibrium. Right? Just a short. We don't write that in the exam, but you need to know as equilibrium means EQM. So, write increasing pressure favors reaction side with lower number of particles. What is the changes what change is happening here? Is pressure increased or decreased? Decreased. So we look at the second rule. Now, Anas, based on the second rule, and I'll also give you the formula right here. ICl plus Cl2 gives us ICl3. Now tell me, where will the equilibrium shift? Forward or backward?
Wait, decreasing pressure favors. So forward.
Forward. Now tell me how many particles are here? on this side, on the reactant
Particles.
side.
So, wait, does it mean like I count the ICL and then
No,
CL?
no,
No.
no, Anas. All you have to
Just-
do is count the number in the front. So we
Oh,
have
so
one
that's
here.
one.
How
So
much is
that's
it?
2. And this side
Now,
has
Anas, I will only teach you things once. Okay?
okay.
And after that, I will not teach it again if you don't have the notes and stuff. So please write if you have not written this, write it right now. Pressure effect
Okay.
on equilibrium.
Yeah, once again.
Now, so this is 2 particles. Now, before you write it, let's first solve the question, all right? Now, how many particles do you think is on the product side? On the product side, how many particles?
Okay. I'm on second one right now. All right, done.
All right, how many particles are on the product side?
On the product, there's only one.
1. Okay. Now I'm decreasing the pressure. So that the rule says that decreasing pressure favors side with higher number of particles. Which side has higher particles?
Reactant.
Reactant. So where will the, so I'll just write here, since reactant has higher number of particles, result will be, what will the result be? Equilibrium shifts.
So
Which
it's
side?
number to the left side.
So equilibrium shifts backwards or left to reactant side. Or let's just say, yeah, to favor reactant side. Any questions?
No.
Perfect. All right. So that's it. Next up, read the second question, second part.
Okay.
What would you observe?
That what you would have.
Observe. Okay. So let's write the observation here. Now, let's say, unlike the last reaction, okay, the reactant is brown. Reactant is brown, and is it brown? Is it? Yes. And the product is yellow. Now, which side is the reaction going, Anas? Backward or forward right now?
Wait, can you repeat the question?
The question is there which side is the reaction going? Which side is the equilibrium shifting, forward or backward?
Backward.
So what more will I get? Will I get more yellow or more brown?
Or brown.
So I'll just write, let's write over here. So the answer will be more dark brown liquid observed. Any questions?
No.
All right, good job. Now let's see. That's done. All of that is done. Next question then. Now, Anas, therefore you have to try to look at your notes and keep revising them. Okay. Let's look at the next question then. Let's try question number 2. Now, I won't help you in this one. You have to do it on your own, and I'll tell you if you're correct or not. Start. Read the question.
Reversible reaction can come to equilibrium. The following are three examples of types of gaseous equilibria. Explain the term
Okay.
equilibrium.
Say it. Tell me what is equilibrium.
Yeah, so equilibrium is rate of forward reaction is equal to rate of backward reaction and concentration of reactants and products remain constant.
Constant. Two out of two. Good job. Now, next question. This one. Read the question.
The following graphs show how the percentage of products of a reversible reaction at equilibrium could vary with pressure. For each graph, decide whether the percentage of products decreases, increases, or stays the same when the pressure is increased. Then match each graph to one of the above reaction and give a reason for your choice.
Okay. So what will happen to the yield of the product? You know what yield means? What is yield, Anas?
Yeah, the surrounding the area.
Yield. What is yield?
Is it the width, like how far it is or something?
Not at all.
Oh.
Now that tells me that you are not paying attention in class, or you're forgetting after class. You're not revising after class. Now in the last class, you should remember that I told you yield is the amount of product.
Yeah, I wrote this.
Oh. Good. Now you remember. Good. Right.
Yep.
So they're asking us what will happen. So if I have any reaction, let's have the reaction SO2 plus O3 O2 gives us SO3. Now this reaction, okay? If I'm going backward, if I'm going forward, whose yield is increasing? If equilibrium goes forward,
The back side seal.
no, this is decreasing, because look what's happening is these guys are turning into this,
Oh,
right?
okay.
So this will go up and this will go down. Does that make sense? Because going forward means that these more of this will become this. Is that clear? So these will join together. Both of these will join together to make this. And that tells us that this will go up and this will go down. So if I go forward, then the yield of the forward reaction is increasing. Is that clear? Now what happens if I go backward? Whose yield is increasing? Reactant or product?
Reactant.
Reactant, because more of this is now forming this. Is that clear?
Yep.
So fine. Now we'll look at this right here. They're telling us this is the graph. Or if I can also show you what happens. Let's say. Now, Anas, can you tell me which side has more particles? Or how many particles are on the reactant side?
3.
3. Good, that was quick. And on the product side?
1.
So if I decrease pressure, if I increase pressure, which side will be favored, forward or backward? If I increase pressure?
Backward.
No, increase pressure, not decrease, increase.
Oh, increase to forward.
Forward, increasing pressure favors less number of particles. And decreasing favors more. So if I increase pressure, forward is favored. A yield of forward increases. Right? Can I say that? If forward is favored, then the yield of forward is increasing. So forward yield of forward reaction is favored. Is that clear?
Yes.
Now, so I can also say let's say it like this. Forward reaction is favored, yield of product increases, or yield of product increases, right? So if I make a graph of this, like this, on the y-axis, I'm going to have the yield, and on the x-axis, I'll have pressure. Now, right now, this is what the graph looks like. Well, no, this is what the graph. Okay, just a second. If you have a graph like this, or let's say yield of product. Then what does the increasing pressure do to yield of product? What does increasing pressure do to the yield of product?
Increasing pressure increases. So forward reaction
Is favored. And so if forward reaction is favored, therefore, what will happen to the yield of the forward reaction? It will increase. So if I increase pressure, let's say on 0, the yield was 10. Okay, or let's say if I have a graph like this on, let's say, if my graph begins over here, at 5, yield was, let's say, at 5 pascals, yield was 10, or at 500, yield was 50, yield was 10. So if I go to 100, what will happen to yield? Will it increase or decrease? Let's talk to me. Now what's happening is,
Sorry,
I
I
am
need to
all right. Now can you hear me?
Okay, so if it's 100, then it's going to be 20, right?
20. Good job. You're understanding. Alhamdulillah. Fine. So yield will go like this, right? Now if I make it even higher, 200, what will happen to the yield? Will again increase? Double again like this. So do you see that the yield is increasing whenever I increase the pressure, right? The line is like this, goes up.
Yep.
Okay. So we'll do it right here. Now we have this graph given to you, okay, where product at equilibrium is 0, pressure is 0, and if you increase the pressure, then the product also increases. So let's write it right here. What is happening to the percentage product at yield at equilibrium? Is the product increasing or decreasing? What is happening? Increasing. So we'll write it right here, increasing. So can you give me the reason?
Constant.
It's not constant, it's increasing because the pressure is also increasing, right? So let's say if this is 0 here and 0 here, and let's say 5 here, this was 10 here, or 10 here. But when it goes to 20, okay, it also goes to 10, like this. So yield is increasing, or the percentage product or amount of product is increasing with the pressure. Does that make sense? Graph is going upwards.
Yes.
So effect of percentage on products, the product is increasing. Can you tell me what type of reaction is it then? Or just a second. So product, right? So which reaction is being favored here? Product or reactant?
The reaction?
Yeah, which reaction is being favored? If the product is increasing, reaction? Forward reaction. Good job. What is the reason?
So if the yield increases, then forward reaction is favored.
Okay. Yield increases, not yield increases, pressure increases, right?
Okay.
Pressure increases, then forward reaction is favored. But I want to know why is it favored? What is favored by high pressure? Check your rule.
One second. What is the rule for yield?
Increasing pressure.
Increasing pressure.
Tell me.
Because it's being heated up.
No, not at all, Anas. The rules for the pressure effect of pressure on the yield, on the equilibrium.
Oh,
It's right
pressure.
here on the board.
Okay. I have it. So, increasing pressure favors reaction side with lower number of particles.
Particles. So what will I write here?
So
The reason is increasing pressure favors
lower side.
no, not lower side. Side with
Lower particles.
lower number of particles or less particles. Fine. Now, Anas, the reaction you have to choose it from here. Okay, you have 3 reactions. So which of these do you think, if I increase the pressure, will go to the product side? If I increase pressure, it should go forward. So which reaction is that?
So if you increase the pressure, it will go forward. So
It should go forward. So is it 1, 2, 3?
It's 1.
1, okay. So let's now look at the number of particles on both sides.
So that's 2, and then that's also 2.
That's 2, and that's also 2. For the second one,
it's going to be 4 and 2. And for the third one, it will be 4 and 1.
4 and 1. Check again. Third one.
Yeah, it is 4 and 1.
No. One more time. Look at the arrow.
Oh, okay. So it's 2 and 3.
3. Now fine. We have this reactant and product. For the reaction, for one reaction to be favored, when the pressure is increased, that side must have lower number of particles. Okay, and since I know the product side is increasing here, okay, so the product must have lower number of particles than the reactant. For which is the case here? For which reaction is that the case? That the product has less number of particles than the reactant. Because increasing pressure only favors the side with lower number of particles.
It's 1 and 2.
No, but 1, they're same. So in same, it will not. So same, it will be no change.
Okay, 2.
Then 2. So because look, the product is being favored, and product will only be favored if it has less particles. Therefore, it must be 2. It can't be 3 because product has more. So because it will cannot be 3. Let's write here.
It's like the same thing, but it's on opposite sides.
Opposite side. So, but the problem is, then the reaction will also go opposite. So, which, if I increase pressure, which side will be favored in the reaction 3? Tell me.
Is it like that? 2AB is the product, and then the other one is the reactant.
All right, that's correct. No, it's not like that, Anas. Anas, always the forward one is the product. Is that clear?
Yep.
हमेशा जो आगे है, that's the product. Now tell me, if I increase the pressure, which side will be favored in reaction 3?
If you increase, then the part with lower number, so the reactant.
Reactant. Good job. Good job. So, but over here, what is being favored? Product or reactant?
Reactant.
No. This one, look. Effect on the percentage of product. What is increasing? Is the reactant increasing or product increasing right here?
Oh, the product is increasing.
So it cannot be 3 because reactant will increase in 3. In 2, the product will increase. So this must be reactant. Reaction number 2. Reaction number 2. Now, Anas, please just explain this question to me one time.
Okay.
Yes. Part 1, how do we answer this question? What is the question asking you? And explain all of it to me. Imagine you are the teacher. Good.
Okay, so this part only, right?
Yes,
So
only
the
part
effect
1.
on person, okay, can you read the question?
No, you have to read the question.
You're the student.
No, it doesn't work like that. Well, I am the student, but you are explaining it to me. Let's
Alright.
imagine I've read the question already.
Okay, so the effect on percentage of product. So to find that, you have to understand the graph. So it's increasing. So the effect on percentage of products is increasing. And then
Good
for
job.
reaction, so if the effect on percentage of products is increasing, then the reaction should have the side of the lower number. Wait.
Okay.
Yeah. And for the reason increasing pressure favors side with lower number of particles.
Okay. Now answer the second one then. Read.
Effect on percentage of products. So
All right.
it's constant.
Constant. Good job. मतलब समझ आ रहा है, right? You're understanding.
Yes.
Right? Good job. Okay. Alhamdulillah. Let's see. Reaction. Now, which reaction will be same? So for it to be same, then both sides, the number of particles on both sides must be the same.
So reaction 1.
Yeah, sure.
And the reason is
Reaction. The reason is
it's constant because both reactant and product have the same number of particles.
oh my God, Alhamdulillah, very good. So both reactant and product have same number of particles. That's like full marks. Good job. So I wrote this, and the mark scheme has exact same answer. 3 out of 3.
All right. Thanks.
Now we have one more. In this, another graph, which you have to answer. Now look at the question, read it, tell me the answer.
Okay, so effect on percentage of products, it's decreasing.
Okay.
Is it from the same question?
Same question.
So decreasing means reaction number 3.
3? Why 3?
Because, wait, can I see the reaction?
Yes.
Okay, so for 3, the product side is greater than the reactant side. So it's decreasing because decreasing the pressure means you have to have like the higher number of particles.
No, you have to have the lower number of particles, right? If you want to increase the pressure.
Yeah, increase you need to have the lower, decrease you need to have the higher.
Higher. So since I'm increasing the pressure, so it's going backward, right? So therefore reactant is increasing, therefore the product must be decreasing.
Yes.
That's what's happening. So what is the reason here? Reaction 3, not that one, this one. The reaction is 3.
Yeah. Isn't the graph decreasing?
The graph is decreasing, but the pressure is going up, right? Pressure is now, it was 5, that was 10, it was become 15, but the equilibrium is going down, right?
So it's going
Y-axis
to be going down. Okay.
So reason is
decreasing the pressure, increasing the pressure.
okay.
Increasing the pressure favors
Favors
the like the side with the lower number of particles.
side with lower number of particles.
Yeah.
But we won't say the side, we'll just say reaction side.
Okay.
Okay. Now, one thing that's fine, but we need to write one more thing. Then why is product decreasing? So I need to write which side has greater number of particles, product or reactant in reaction 3. Tell me.
Wait, so the product is decreasing because the product side is has the higher
All right,
number,
product is decreasing because product side has higher
particle number, higher number of particles.
That is what you have to
Greater
write. Now you
number.
did it on your own. That's full marks again. Okay, so memorize the rule and use your brain to answer the question on why it will happen. So because look, since it has higher and you're increasing, so it is going to the reactant, and since reactant is increasing, the product is decreasing. 3 out of 3. Any doubts on us?
No.
No. Then we'll try one more question on this. Can we? Are you ready?
Yeah, sure.
Sure. All right. Now let's try this one. Read the question.
Okay. Nitrogen dioxide is a brown gas. It can be made by heating certain metal nitrates. Name another metal whose nitrate decomposes to give the metal oxide nitrogen dioxide and oxygen.
All right. And that's what are nitrates, by the way? What is a nitrate?
I don't know.
I'll tell you. Any compound with NO3 minus ion. Is that clear? Any ion with?
Okay.
Any compound with which, read this out loud. Write it in your notebook.
Yep.
Oh, wait, by the way, we'll just see what a nitrate means. This is called nitrate. So nitrate ion with, and let's just write it like this. Any nitrate, let's say nitrate compound is equals to any compound with nitrate ions. So nitrate ion is NO3 minus. Write this in your notebook. Tell me when you're done.
Okay. Done.
Done. Now that means any compound with nitrate ion, right? So they're given us Pb. What is Pb? Pb is lead. What is it?
Lead.
Lead. That's the symbol. Now for every atom, if you have, let's say Cl, it starts with capital letter, and every second one is small letter. You need to know that this is one.
Yeah.
Right? It's one symbol. So all symbols start with capital letter. So Pb is 1. You can't say P is 1, then B is 1, then O is 1. No. Every starts with the capital letter. So this is Pb, and that's O. We have lead nitrate here. Lead nitrate. What other nitrate can I have? I can have any other metal. Name a metal and ask quick.
I don't know any nitrate.
Any metal.
Metal. Copper? No, copper is not a metal.
Copper, right? Done, easy, right? So any name another metal that whose nitrate decomposes to give metal oxide, nitrogen dioxide, and oxygen. Now please write this in your notebook. Decomposition, let's just say thermal decomposition of metal nitrates. We'll just write except group 1. Write the answer. It's always going to be M NO3. I'll give you some examples. There are two possible ways. You can have yes, so M NO3. Gives us, or write in your notebook. This is called decomposition of group 2 nitrates. So decomposition of group 2 metal nitrates.
Okay.
And the general formula is given right here.
What is M?
M is any metal. It could be, we'll have to look at group 2 first. I'll show you the periodic table. Can you see the periodic table right here? Now, Anas, where is group 2?
Group 2 is the second group. So
All of these.
BeMgCa, yeah.
Beryllium, magnesium, calcium, strontium, barium, radium. Right? Don't have to memorize it. I have it memorized, no worries. So beryllium, magnesium, calcium, strontium, barium, radium.
So
All of these, those are group 2 metals. Okay?
Oh,
Both group 1 and group 2 are metals. But group 1 is called alkali metal. Okay? And group 2 is called earth metal. Well, both of them are metals, but they're different. This is group 1, that's group 2, right? So group 1 is different from group 2.
The next one, the whole line that's blank.
This one?
Yeah.
These are called transition metals. What are they called?
Transition metals.
Now they're not group 2, they're not group 1. They're literally called transition metals.
So there is no group 3, 4, and 5.
3 is right here, 13. This is group 3, 4, 5, 6, 7, 8.
Okay.
Right? These over here are separate. Right?
So they're just transition metals.
They're just transition metals. Yes. Transition.
So copper is one of transition metals.
Yes, obviously. Copper is one of, name another transition metal. Quick.
Cobalt, iron.
Cobalt, iron, all of them. So we're not looking at those guys. Yes.
Yeah, when I was in like 8th grade, we did the lesson on periodic table and we had to like draw a picture of something related to the one we pick.
I see. All right, makes sense. Now these guys are called non-metals. What are these? Non-metals. Clear? So we have metals, everything is metal, alkali metal, earth metal, transition metal, and non-metals. Fine. Now we're only looking at group 2 or earth metals, group 2. So I'll start with, let's say, calcium. Let's start with all of this. Just a second. Right. This will give me, now Anas, write this down. This will give me 2CaO plus 4NO2 plus O2. Write this as an example, EX. Let's say example number 1. Tell me when you're done writing. Just below the general formula, remove the word general formula from there. Just write example, and below that we'll write the general formula, which is 2MNO3 to, write it all quick. 2MO plus 4NO2 plus O2. Do you realize what I'm doing? All I'm doing is replacing the M with Ca, right? And you can do it with all of the metals. You can put in place of M, you can write barium, you can write magnesium, beryllium. It's your choice. Now I don't want you to take a picture. I want you to write this. Have you finished writing?
1 second. Done.
Done. All right. Now let's go back here. I want you to complete the word equation for this. All right, just a second, just a second. Now, okay, right over here. Just below this, I want you to write thermal decomposition of group 1 metal nitrates. So we did group 2, now we're doing group 1. Now, as you may realize that this is not from chapter number equilibria, right? Not chemical equilibria or reversible reaction, but this is still in your book. So you have to finish this as well. Now we'll start with, just a second. I'll give you the full formula here. All right, this is what you get. Now, let me open it. Let's write it. So I'll start with an example first. Example 1. Example 1 is 2Na-NO3 gives me 2Na-NO2 plus O2. Is that clear?
Yep.
Perfect. Now write the general formula for this. The general formula is going to be, all you have to do is replace the Na. You can use any group 1, right? So 2MNO3. Amina, good evening. Can you hear me?
Yes, sir. Good evening.
Welcome to class. Now, what subject do we have?
Bio.
Bio. All right, just a second. I'll finish this chemistry class and we'll start bio. Now, Amina, how are your grades in chemistry?
Me?
Yes.
Like around 60, 70 out of 100.
Well, so what are your expectations from IGCSE? Are you hoping for an A star?
Not A star, but A.
A. All
Yeah.
right. So A is at 80%. 85% is A, and A star is 95%. So
Oh.
you need to crank up those numbers, right? Because those are rookie numbers.
Yeah.
Because 70% or 60% is going to be 70 is going to be a C, and 60 is going to be a D, right? Now I think it's very easy to get A stars in IGCSE. So you shouldn't hope for it. If you hope for A, then you'll get a B. If you hope for an A star, you'll get an A. That's how it works. Now Anas,
Yeah.
finish writing quickly. Anas, are you writing?
Yeah.
All right, finish writing quickly, and then you'll have to finish the assignment which you have in the GCR for this. I think we have done 3 questions. You have 3 questions remaining. You can do it, right, Anas?
Yep.
So you also have stoichiometry, some of the stoichiometry questions there. And if you don't understand something, just skip it and ask me later, because I need you to get an A star, right?
Yep. Right.
Work hard.
Right.
Finished?
Yeah.
All right, just a second. Now, Amina, have you done this in class? Thermal decomposition of group 2 metals and group 1 metals? Have you guys finished? Anas? Amina, Anas, are you in the same class?
I don't know.
All right, no worries. Just a second. Now, Anas, write this in your notebook. Next class we're going to do. Our next class is a homework submission.
Okay.
And after that, we have something which is, we'll be starting a new chapter. So think of a chapter which you want to start.
All right.
All right, just a second.